So, welcome again to the HARTING Experts Camp and the next webinar of the Industrial Ethernet Trends. My name is Ralf Schobert from HARTING Electronics, and I will guide you through the next hour. Yes, we have an exciting topic today. I'm looking forward to, especially to my colleague Fabian Peper, our expert for today. But yeah, before we start, I just want to give you some information about today's webinar. Our webinar lasts about 45 minutes, and in the last 15 minutes, we have enough time for your questions. If you have a question, simply ask in the questions window on the right side. You're welcome to ask questions during the presentation. We will take up your questions after it. And we will also record the webinar, after which you will receive a link to the recording. In this webinar, we will focus on the megatrend single-pair Ethernet and its role as a game changer of IIoT. Our expert is my colleague Fabian Peper. He's Global Campaign Manager at HARTING Electronics, and he's an expert in industrial connectivity. Before we start today, let's first hand over the word shortly to you. We thought it would be good if you and we could get an impression of how relevant SPE already is for you today. And yeah, we will do the whole thing in form of a quick poll. Doing so, we would be able to see the result in a few moments. So it would be great if you would vote briefly. And here comes your question. So the question is, SPE is changing industrial communication, but is still in its beginning. How relevant is SPE a new company already today? So, and we have prepared 4 possible answers. Answer A, very relevant. We want to use SPE and plan a design in. Answer C, very relevant, but we have not planned any further steps. Or answer C, relevant. We are currently learning about the technology. Or answer D, it's not relevant. We do not see any starting point yet. Yeah, and we will give you a couple of seconds to vote before we share the result with you. So take your time. Okay, there's still some people voting. Let's wait another moment. Okay, thank you. The poll is then closed now. And this is the result. Yeah, that's interesting. So 47% of you say it's relevant, but we are currently in the start of getting information. And 14% say it's not relevant. You don't see any starting point yet. And yeah, with that, we are on today's topic. And I want to warmly welcome my colleague, Fabian Peper. Fabian, hello, can you hear me?
Thank you, Ralf. Hello, everyone. Thank you for your time that we are able to talk to you about single-pair Ethernet today. And I think, yeah, this poll is very interesting. So a lot of you are very interested in single-pair Ethernet, but you don't have a real starting point yet. And but maybe and I hope so, we can give you the starting point today. And let me share my screen and give you an overview of single-pair Ethernet. Before I get started with the topic of single-pair Ethernet, I want to introduce our company, the HARTING Technology Group, to you. HARTING is a 100% family-owned company, and we are working in the industrial connector business. We are focusing on the 3 lifelines for the connectors of data, power, and signals. And we made last year approximately 750 million euro in sales. We have around 44 sales subsidiaries, 14 production plants throughout the world. Our headquarters is based in Espelkamp in the north of Germany, and we have currently above 5,000 employees. That's what I wanted to tell you about HARTING, and now I want to get started and want to show you what the topic is today and what the agenda will look like. So first of all, I will start with the IIoT development. why do we need a change in the Ethernet network infrastructure? Single pair Ethernet will change the Ethernet network infrastructure, and I want to show you why this is relevant. After that, I want to show you all for Ethernet, our solutions from HARTING for industrial applications for Ethernet connectivity. The next big step is the game changer for the IoT, single pair Ethernet. I want to talk about standardization. If you want to establish a new technology in the market, you need standards. That's why we will talk about standardization. After that, we want to show you where you can use single pair Ethernet, in which applications, and what kind of products can you use, are we offering as HARTING to you for single pair Ethernet, what kind of connectors. And after that, we will talk about the single pair Ethernet industrial partner network. This is a gathering of lots of companies focusing on single pair Ethernet and want to establish a whole ecosystem for single pair Ethernet. And at the end, we will have time for some questions and the answers. Let me start with the challenges of the industry we are facing currently right now. So what we are having is right now we're talking a lot about the Industry 4.0. Industry 4.0 is already now taking place for several years, and we are already talking about it. And with the Industry 4.0, there comes a change of products and services. So everything is digitalized. We have a digitalization of new business models, digitalization of products and services, and digitalization of value chains. And what kind of products and services do we have there? For example, location detection, authentication, advanced HMIs, 3D printing, customer interaction, smart sensors, big data analytics, augmented reality, IoT platforms, cloud computing, and mobile devices. And all of these products, services, value chains, and business models, they somehow want to interact with each other and need a solid basis of Ethernet communication, and they are all based on Ethernet communication, which is hardwired. So on the basis, everything is based on Ethernet. And I want to show you now how this IoT market and this Industry 4.0 market is currently developing. So each year, the global Industry 4.0 market is grown by 37%. And what does this mean for the cabling infrastructure, for the Ethernet infrastructure and communication infrastructure? So in 2018, the industry Ethernet had already a market share by 52% and an annual growth rate of 22%. Field buses compared to that have only 42% and an annual growth rate of 6%. So we already see that there's some sort of change. And in 2019, this change takes even more place, where industrial Ethernet has 59% market share with still an annual growth rate of 20%, and field buses only 35% with an annual growth of -5%. So field buses become less important market share-wise perspective compared to the industrial Ethernet. And in 2017, there was the change between industrial Ethernet and field buses. So in 2017, the industrial Ethernet had more market share than field buses. And if we now look at how these field buses and industrial Ethernet take place in the automation, then we have a quick look at the automation pyramid. So industrial Ethernet is all above here. Everything what is above the control level, supervisory level, plant management level, and enterprise level is used as industrial Ethernet. And everything what we have in the field level is field buses or analog signals. And this is still how it's set up today. And I want to show you what kind of products we as HARTING offer for Ethernet for the basis of industrial cabling and industrial communication. So we start off with the Ethernet of the basis of known interfaces like RJ Industrial, which is a standard in the industrial communication. Pre-link, a field assembly connection method for the RJ Industrial. Also cable assemblies, and if you want to have a higher protection degree with IP65 and 67. You can use the M8 and M12. Port solutions, also modules for the HAN modular with the HAN RJ45 or gigabit modules, and also our own switch series, the Harvest Econ series. This is everything what we have for as known interfaces, which are already there for a couple of years. And now we have, of course, expanded our portfolio with new solutions for the industry, with, for example, the iX Industrial. The iX Industrial is a connector which is specifically designed for industrial applications, for harshest industrial applications. And it is based on 4-pair Ethernet, so you can transmit data, but you can also transmit signals. And later this year, we will launch an IP65-67 version, the iX Mini Push-Pull. It's with a push-pull locking mechanism, so you really have a safe connection for your data and signals. And today's topic is the Ethernet for the future. And the Ethernet for the future is single-pair Ethernet. Now, how does single-pair Ethernet change to existing Ethernet protocols? So this is what I want to talk to you first about. What is single-pair Ethernet and how does it differentiate to the existing Ethernet protocols? So we start with Fast Ethernet. Fast Ethernet is already there for several years. It is widely used by Profinet and is based on 2-pair Ethernet. So we have 4 copper wires in total. We have a transmission rate up to 100 Mbit and a transmission length up to 100 meters. The next Ethernet is Gigabit Ethernet. Gigabit Ethernet, you can transmit up to 10 gigabit of data for 100 meters. And you already see that we need more wires, so we have 4-pair Ethernet here. And with single-pair Ethernet, as the name says it already, we're only using 1 pair, so we're using two wires only, 2 copper wires. And we have 3 different standards for single-pair Ethernet. The first one is the 10 Mbit standard for 1,000 meters. The second is a 100 Mbit standard for 15 meters, and the 1 gigabit standard for 40 meters. Now you ask yourself, why does the 100 Mbit standard only go for 15 meters and not for 40? Well, we have to consider where this whole technology is coming from. Single-pair Ethernet got originally invented in the automotive market, and cars aren't usually longer than 15 meters. And after that, the industry adopted this technology and said, well, this technology is very interesting, but we need longer distances. That's why other protocols and standards got established, like the 10 Mbit standard and the 1 gigabit standard. Last but not least, if we compare also the cabling, the diameter of the cabling, this will also change dramatically. Because we are only using 1 pair, we are having a huge weight saving regarding the cable and also the diameter for the cables. And when I'm already talking about standard, then I want to really emphasize that we set new standards. We as HARTING set new standards. And the picture, what you see here, is our new T1 Industrial. This is the connector for single-pair Ethernet. And I want to first go to the IEEE standards, which are very important. So we have 4 different standards. 1 is currently under preparation and 3 standards are published. The first standard is the 10 Mbit standard, which is standardized in the IEEE 802.3 CG. And it is approved for 1,000 meters transmitting 10 Mbits. The 100 Mbit standard, you can transmit in the standard written down 15 meters with an unshielded twisted pair. But we as HARTING tested internally that you can also transmit 40 meters with a shielded twisted pair with our certified cables. The 1 gigabit per second, you can transmit 40 meters with a shielded twisted pair and 15 meters with an unshielded twisted pair. And the last standard, which is currently under preparation, is the multi-gig standard. This standard can transmit 2.5, 5, or 10 gigabit per second for up to 50 meters with a shielded twisted pair. And as we can see here on the right, we have different bandwidth for different transmission rates. So the transmission, the bandwidth goes higher, the higher the transmission rates is. And we already have 600 megahertz for 1 gigabit, and already 4 to 5 gigahertz for multi-gig Ethernet. And if we now take all these standards, and now we want to see how these standards got developed and who is all participating and whose decision is it. So this is the international standardization process, and the standardization process is done by the IEEE 802.3. They are responsible for the Ethernet protocols, and to 80% they talk mostly about semiconductors. Semiconductors are very important because they define the Ethernet protocol on the chip. But you also have to consider to have a real connection and to have a good connection between two devices, you have to consider the whole link segment. And that's why also cabling systems and cabling standard organization also participate in these in the standardization process. With the ISO IEC and the TIA for the American market, two cabling organizations are participating and are trying to evolve and help the IEEE to get their right standard. And what we have also, what we've done as HARTING, is we standardized our connector, the IEC 63171-6. This is our standard, which is published in February this year, and everyone can buy the standard and design their own T1 industrial, their own product for single pair Ethernet according to this standard. And also the cabling must also be standardized, which we also have. And the IEEE said, well, yeah, because a lot of companies can standardize their products, their connector for single pair Ethernet. And there is a widely range of different connectors at the market, which are currently in standardization. But what the IEEE said, well, yes, they can standardize different mating phases, but we want one mating phase for applications. And they talked to ISO IEC and TIA and said, well, please, can you make a voting and decide which interface you have we want to use and you have to use. And in the standardization and in the selection process from TIA and ISO IEC, the outcome is that for harshest industrial applications, the IEC 63171-6, this is our connector, our mating phase from HARTING, must be used for single pair Ethernet. And this is also what the ISO IEC and TIA said after that. To have a standardized and connection for harshest industrial applications, you must use our connector, the IEC 63171-6. This is very important. And if we now look at the whole process again, where we started and what kind of things and steps you need for single pair Ethernet to establish it as an IIoT standard. What you first need is a proposal of a mating phase. We did that. This mating phase was reviewed and released by the IEC in February 2020. The next step is the selection process and the global validation. So IEEE said and talked to ISO IEC and TIA, please define an international standard for a single pair Ethernet mating phase. And in this selection, they voted for the IEC 63171-6, the industrial style for harshest industrial applications. And in the next step, ISO IEC and TIA and all the cabling standards, they have a broad commitment and said, well, the decision is made. The IEC 63171-6 must be used for industrial applications. And the first IIoT pioneers adopted the single pair Ethernet technology with it's a gathering of different companies, and they unified to a single pair Ethernet industrial partner network. And this industrial partner network focuses and has a commitment to the IEC 63171-6, and they want to develop early solutions and build a whole ecosystem. Now, we have talked all about standards. Now I want to dive into applications and where how the industry will change with single pay Ethernet, how the cabling and the infrastructure will change. And we will again start with the automation pyramid. And because the automation pyramid is always very important to see what kind of protocols and on what kind of levels we will have which infrastructure. And we start with the ERP level to the PLC level. Right now, standard Ethernet is used, or industrial Ethernet for PLC applications. And in the field level, right now, we don't have any Ethernet technology. We are currently using field buses and analog signals. With single pay Ethernet, this will change. With single pay Ethernet, we have the opportunity to talk one common language from bottom to top. So single pay Ethernet will not change the existing infrastructure of RJ45 solutions based on 2 or 4 pair Ethernet, but it will complement the whole technology. So with single pay Ethernet, you can really access the field level with a small mating phase, and each of these devices has, for example, their own IP address. So TCP/IP communication is now possible to target really TCP/IP communication from bottom to top. And that's why single pay Ethernet really is the answer for the field level, the Ethernet for the field level. And if we now look again at the existing field level, what kind of protocols we have, then we already see that there's some sort of problem right now which we all are facing. So what we have different field buses: Profibus, CANopen, Interbus, DeviceNet, CC-Link, Modbus RTU, and all the others. They all are different protocols, and they don't communicate with each other that easy. You always need translation. And what the IEEE standard, the 10BASE-T1 long standard, can do is that all of these field buses don't go usually beyond 1,000 meters and don't go beyond 10 Mbits. So with this new standard, the 10BASE-T1 long, you really can make a continuous TCP/IP communication possible, and don't need that many translation processes and media converters to convert from one protocol to the other. If we now talk about different applications for the 10BASE-T1 long standard, then we talk about first of all the 10 Mbit standard, which can be used in train, tram, and bus networks, because you have very long distances you have to cover. Also in factory automation, where you have sensor and actuator networks, also with long distances. Medical technology, and also machine control and measuring and control technology. For example, if you have in a production, you have five machines of the same kind of machines. On each machine you have the same HMI or the same monitor, and with single pay Ethernet you can just easy it up a little bit, only using one device and going with cables to each machine. The same with 1000BASE-T1 for 1 gigabit. So for HMIs, you can use the 1000BASE-T1 for HMIs. Of course, you can also use it for train application. It always depends on the application where you want to use it. Production control and monitoring cameras, mobile working machines, motion drives, and robotics. Especially the less tension, because of the smaller cable, is highly important, and it's more life lasting than thicker cables. And also industrial PCs and monitoring can be used with the 1000BASE-T1. But of course, it always depends on the application, and you already know your applications as its best. But this is just an introduction and just a imagination of what kind of application single pay Ethernet can be used with. If we now dive a little bit deeper into these applications, look inside a cabinet, what can happen there? There we see that, for example, we have here a cabinet with a PLC, with I/O ports, an Ethernet switch, power supply, and vision system controller. Now, where can I use single-pay Ethernet? Inside the cabinet, we have an IP20 version for single-pay Ethernet, and you can connect their PLC to an Ethernet switch, for example, and also from the Ethernet switch to the vision system controller. But also, if you want to go outside the cabinet, and this is also very important, we have a IP65-67 version which you can use. Also, different field applications devices like vision camera systems, proximity sensors, HMIs, and robotics, a robotic arm can be used with single-pay Ethernet. So you get just an imagination of what kind of application single-pay Ethernet goes along with. And basically, there's also no boundary regarding these applications. Everywhere where Ethernet can be used, single-pay Ethernet can be used, and yeah. Also, we have different applications with the T1 Industrial, which are already happening and taking place, and already are being used for test applications. For example, we have a technology study for single-pay Ethernet switch with a T1 Industrial with 5 ports and 2 RJ45 ports. This already is tested with the automotive chips, because this whole technology comes from the automotive market. To the components which are needed for single-pay Ethernet, I will come to that in a minute. But first, let me talk about these other products, like single-pay Ethernet automotive camera, and also I/O module with the T1 Industrial, so with single-pay Ethernet, and also another switch with an M8 snap-in interface. And now, after these applications and possible applications, I want to show you our connector family, which we are launching. So this is our new connector family. We have one new mating phase. This is this one, with the IP20 plug, and all of these, this one mating phase goes into 6 different housings. And the IP20 version is the first version we will launch, and where we will make samples available later this month. And we will follow by the M8 snap-in version, an M8 metal push-pull version, but also as a screw version. And now you probably ask us, why do we also need M12 when we already are having M8? Well, for longer distances, you have higher power loss on the cable. That's why you need a thicker cable, and this thicker cable with AWG18 is not fitting into the M8, and that's why you also need, for longer distances, the M12. Also for applications like train applications, M12 is widely used and is appreciated by the market. And what we also have is that the receptacle is also a 2-in-1 receptacle. So the socket is also for push-pull, but also for screw termination. This is also very important, so your customer or you can decide later whether you want to use push-pull or screw as a locking mechanism. And the question, why have we designed our interface the way we designed it? Because with single-pay Ethernet, we can transmit a lot of data, up to 1 gigabit right now, and higher data rates are currently developed. Our mating phase is future-proof. If we don't have a symmetrical interface, you don't have the best signal integrity, and that's what we can ensure with a symmetrical design. And that's why we designed our interface the way we designed it. So it's future-proof also for higher data rates, like 2.55 and 10 gigabit, but also for 1 gigabit, because of the high bandwidth of 600 megahertz. There are already problems if it's not a symmetrical design. Let me now talk about each of these products in detail. We will first launch the IP20 version as a crimp version, and after that IDC termination will follow. Also, the first thing will be the PCB jacks with THR holding pins. And we also have a study for a jack with LED light and also integrated magnetics and also multi-port jacks. What is now the main advantages of the IP20 version? So we have 4 robust THR shielding contacts, providing really a robust connection to the PCB. It's reflow soldering ready, and it has a 360-degree shielding concept. And also you need only 50% less space compared to the RJ45 with a very robust locking system. And what kind of application and use case? Well, everywhere where you need have a cabinet where you need IP20 protection degree, single PA Ethernet can be used, like PLCs, drives, I/O components, displays, and so on. And of course, if you now go outside the cabinet, you need higher protection degree. That's why we have, for example, the M8 version. This M8 version will come either with as a screw termination, push-pull locking, or snap-in. And the connectors come first with a crimp termination, and IDC termination will follow after that. Also, the main advantage is the very robust locking system and connector with an 8mm version. We have the identical receptacle for push-pull and snap-in locking system. We have a 360-degree shielding concept, and we have a very compact IP65-67 interface. Also, again, to the applications, they are very similar, but of course, everywhere where you need a field connection with IP65-67 protection degree, the M8 version is a perfect fit for that. Also, especially for sensors and actuators networks, where M8 is widely appreciated and already widely used. And also, especially cabling between machines and production equipment from IP20 to IP65-67 connection, the M8 is also a very good fit. The M12 version will also come with the crimp termination at the beginning, and we of course have the very robust IP65-67 interface, also the identical receptacle for the M12 and push-pull locking system, and for the M12 screw and push-pull locking system, and also this M12 is ready for cable diameters for AWG18 for longer distance, where you need where you have higher power losses and you still want to transmit 10 Mbit over 1000 meters. Application and use cases are pretty much the same everywhere where you need where you have a harshest industrial environment, where you need IP65-67 protection degree. This M12 can be used. We now have also a different M8 version, because sometimes you need more power at your device. That's why we have the M8 hybrid industrial style. The M8 hybrid is also coming as a crimp version, and after that we will have an IDC version. And what is the main advantage now of this hybrid version? Well, you have 2 data contacts for single PA Ethernet and 2 power contacts for 8 amps and 60 volt DC. It is of course an IP65-67 interface and really ready for higher power delivery. That's why we invented this this hybrid version, and also this hybrid version is also written down in the standard. So in the IEC 63171-6, all connectors are all located in one standard. This is also very important. And of course, applications everywhere where you need high power, where you don't want to have a separate power supply, this connector can be used. Now we have talked about the connectors and the applications. Let me now talk about what is all necessary for single PA Ethernet. And for that, we created an ecosystem. This ecosystem shows everything what you need for single PA Ethernet. First of all, we start out with standards. The IEEE 802.3 standardized the base T1 Ethernet protocols, very important. Also, the connector standard is also published, And we also have the ISO IEC and TIA, the cabling standards. And also another standard is a power over data line remote powering standard. This standard is for remote powering, and I will come to that in a second. What other components do we need for single pair Ethernet? We also need different components like new PHYs and switching chipsets, because we are now using only one pair of copper wires instead of 2 or 4 pairs. We also need new magnetics and of course new cables, patch cords. We need a new MDI and of course the plugs, sockets and couplers. The next thing we need are devices, HMIs, switches, sensors, vision sensors, controls, edge computing, actuators, drives, and valves, for example. And also accessory like crimping and assembly tools, and also test equipment like field tester and network tester. And as I already mentioned, regarding the application, basically there's no boundary for single pair Ethernet. Single pair Ethernet can be used everywhere where Ethernet is used. So in transportation, sensor actuator networks, machinery, automation, control monitoring cameras, smart farming, mobile working machines, and robotics. And if we now talk about the power over data line, I mentioned that I want to come to that in a second. I want to show you how this is set up and what kind of components do we need. So again, we need the Ethernet MAC and the Ethernet PHY. So we need the chip for that. We need the magnetics to transduce the signal from the cable to the PCB. Of course, this is needed on both sides. And of course, the MDI connector, and of course, the power over data line controller to use power over data line. What kind of power can we transmit? So for the power device, we can power up the device up to 50 watts with a rated voltage at the power sourcing equipment with 12, 24 and 48 volts. And power over data really is the equivalent for to power over Ethernet. Power Ethernet with 4 pairs, and we have now power over data line with just 1 pair to transmit power. So when we're coming to an end of this presentation regarding the products and the applications, I want to talk about the advantages of single pair Ethernet real quick. So what are the main advantages? The first advantage really is it is an open communication protocol. There's no dependency on a manufacturer. This is all an open communication protocol. We have with single pair Ethernet the possibility to have the infrastructure for the IIoT. That's why it's also the enabler for the IIoT. If you want to do real-time communication, time-sensitive network is a perfect fit for that, which you can use and adapt. Also, you can transmit up to 1 gigabit for automation networks and power over data line, as I mentioned, for remote powering. And one of the biggest advantages, this is a standardized interface. This is not a proprietary solution by just one company, by HARTING. No, this is an industrial standard which can be bought, and other companies can establish and develop their own connectors and products with single pair Ethernet based on the standard. We have with the one pair wiring, we have a huge weight reduction regarding the cabling, coming from 2 pair or 4 pair cabling to just 1 pair. And it is shock and vibration proof, which is also necessary, for example, for robotic application, for harshest industrial applications and train applications. And that's why we have the game changer for the IIoT. That's also the topic of the this webinar. Single pair Ethernet really is the game changer. And if we look back at the beginning of the webinar, where we were talking about the different digital business models and digitalization of products and services and the digitalization of value chains, then we see that all of these products, services, and they all need one new infrastructure, and we want to use this infrastructure, and we have to change this infrastructure, and we want to have a common TCP IP communication from bottom to top to really establish the infrastructure for the IIoT. That's why it is the enabler for the IIoT. We have an open communication protocol. There's no dependency on a manufacturer. There's a continuous TCP/IP communication, real-time communication with TSN, and power over data line, the remote powering standard, to not have a separate power supply, to just power up your actuator with up to 50 watts. And the question, or I already mentioned it at the beginning, and that's why this question is rhetorical. HARTING, are we alone? No, we are not alone. What we did, we invented the single pay Ethernet industrial partner network. The EV is in Germany, it stands for Eingetragener Verein. It's a legal association. And the goal of this partner network is to develop the single pay Ethernet market, to create new business opportunities, to get really concrete in the IIoT in practice, to really live the Industry 4.0. We want to create clarity through standardization. All of our partners committed to one standard, the IEC 63171-6. And what this partner network wants to provide is all the necessary components and equipment what is needed for single pay Ethernet. And we want to get transparency to applications. And now let me show you our founding members of the single pay Ethernet partner network. We started out with HARTING, lloT, Moore Electronic, TE Connectivity, Softing, Hirose, and lloT Electronic. And all of these companies have different strengths and competencies. For example, TE and Hirose and HARTING are very strong in the connector business. lloT will supply cables, and Softing is for test equipment, and Moore Electronic will also have active components. And lloT Electronic will supply everyone with magnetics, for example. And we didn't stop there with the partner network, with the single pay Ethernet partner network, because we wanted to establish the whole ecosystem, and we're still having some white spots regarding the components. That's why we added a few more members like Molex, Amphenol, Perinet, for example, for smart sensors, Egos also for cabling, Fluke, which is also doing test equipment, and also active components like Hirschmann with switches, with a managed switcher for single pay Ethernet. And of course, we want to expand this whole single pay Ethernet partner network, and this could be you. So if you are interested in becoming a partner of this industrial partner network, just hit us up and talk to us. We are all open to all kind of partners. And what is very important with this partner network, and what really is a benefit for you, not only as a partner, but also as a customer, is that everyone committed to the IEC 63171-6. They're committed to one mating phase. And they have committed to the ecosystem, to fulfill this ecosystem. And also everywhere where you see this logo, this brand mark, this is everywhere where you see this logo, the products with this logo will work together. So this guarantees you that this is the right single pay Ethernet to use. And now I want to show you what kind of competencies our partners already have, and where they are already located, and where our partner network, how strong our partner network is, and what kind of devices and components we can already offer. So as you can see, this partner network has a lot of competencies, and of course we're still looking forward to having partners in for actuators like drives and valves, for vision systems, and also HMIs. But of course we are also looking for different other suppliers of components like magnetics or controls, sensors. So basically there's no stop of partners. We really want to emphasize that, and want to really push this partner network forward. And if you have questions about the partner network, we have an own web page for that, single-pair-ethernet.com. We have our own homepage, harting.com, and we created a white paper for single pay Ethernet where you can download your ebook And on 18 pages, we have all the different information about what is single-pay Ethernet, where it's coming from, what kind of standards do we have, and how can I use single-pay Ethernet. And I want to quickly emphasize on the new webinars which are coming up. The next one also regarding single-pair Ethernet is how to establish barrier-free sensor to cloud communication, and also the iX industry mastering the challenges of miniaturization. I showed the iX at the beginning of the webinar, and it is really a product which is made for industry applications. And also the 4 inspiring examples of how single-pair Ethernet enables the IoT applications. And I really want to invite you to those webinars. We will have different topics there, and we will show different experts for single-pair Ethernet. And now I would like to go back to Ralph. Can you hear me, Ralph?
Yes, I can hear you. Many thanks, Fabian. So yeah, really interesting presentation, which is not only my opinion, but what we can also see in the reactions that already have taken place. Yeah, thank you. And yes, we promised, now it's up to you. Please feel free to ask your questions. Fabian Peper will answer them. And yeah, Fabian, as I said, some already came in. Shall we start? Are you ready?
Yeah, sure. Thank you.
Great. So at the very beginning, there was the topic about the 4-chamber system.
Mm-hmm.
Or you quickly mentioned that. So why is HARTING not promoting this more extensively?
Mm-hmm. The 4-chamber system is done by is done by a competitor who are talking about that, and we are not promoting this because this is not a standard. And to establish a whole new single-pair Ethernet technology, we have to rely on standards. And also, there's a technical problem with this approach. If you have high frequencies, and especially if we transmit 1 gigabit per second, it is more likely to have crosstalk if you're using the same cables and if you're using a 4-chamber system. That's why we are not supporting that, and that's why we think this is not the right technology for single-pair Ethernet.
Okay, thank you. Then an attendee asked a question, or some attendee asked questions regarding transmissions length. So yeah, when I try to put all those questions together, maybe a question could be, why have the different SPE protocols have such different length?
Well, that's also a very good question. As I showed, we have 3 different standards. The first standard for 10 Mbit, 100 Mbit, and also for 1 gigabit. And all of these standards come with different transmission length. And the reason for that is it always depends on the applications. The 100 Mbit coming from the automotive market, where we only having a short amount of length, we have to transmit data. And this is for example for 15 meters, and with the 1 gigabit for 40 meters, we can really access highly sensors which have high amount of data. But also, if you want to go long distances, we have a different standard with the 10 Mbit standard. So it really depends on the application.
Okay, so then there is a question about different Ethernet systems. So is it possible to transmit Profinet or other industrial Ethernet systems via SPE?
Mm-hmm. Also a very good question, and a very often asked question. Yes, it is possible because we only change the physical layer, like standard Ethernet or Wi-Fi. So we only are working on that basis. That's why you can also use other industry Ethernet systems like Profinet or EtherCAT. But the user organizations, they also always recommend which mating phase you have to use, and they are currently discussing how to do that and how to use single-pair Ethernet. But there's not a final decision yet.
Right. Some questions are there regarding the mating phase. So bringing it all together, a user asks, so what is the advantage of yours? Well, so there are
Yes.
different mating phases so far. What is the advantage of the T1 industrial?
Yes. So first of all, with our standard, we have a whole complete picture of different housings with just one mating phase. This is very important. The second is we have a symmetrical interface, which I mentioned. So we are future-proof for higher frequencies up to 10 gigabit, which needs 4 gigahertz of bandwidth. Also, we have a 360-degree stainless steel shielding for the best signal integrity. And also, because of the stainless steel shielding, we have a high corrosion resistance and also a very robust locking mechanism with a metal locking. And our product is a highly shock and vibration proof for transportation and robotic applications. Yeah, and also it is an interface which is widely recommended also by the cabling standards and also by our partner network, by lots of companies that already try to work on solutions for single-pay Ethernet with our interface.
Yes, at the very beginning, there was a word about chips. The question is, who will develop these necessary chips?
Yes, this is also let's say a bottleneck for single-pay Ethernet. Lots of companies like Analog Devices, TI, Microchip, Marvel, NXP, and Broadcom, they're already working on those chips because they are necessary to use single-pay Ethernet because we need those semiconductors. And they are already working on that. And for example, Analog Devices, they already have a video up on their webpage regarding the 10 Mbit standard, where they will launch evaluation boards this summer and also start series production next year. And also, if you want to test single-pay Ethernet right now, you usually don't go for long distances. You don't set up a test application for 1,000 meters or 40 meters. But for that, we can already refer to automotive switch and chips, which are currently already available and which you can use for test applications.
As we are talking about chips, there's a second one about chips, a little bit different. So you mentioned the SPE Industrial Partner Network. So are there so far any chip manufacturers on the horizon inside
Well,
this network?
yes. Well, the chip manufacturers, they don't really have the the purpose behind that to go into this partner network, because they don't rely on any connectors, because at the end it doesn't matter what kind of connector you put on the PCB for single-pay Ethernet in their perspective. From their perspective, but all semiconductors manufacturers support this technology, but they remain neutral regarding a mating phase. But they are all working on that, just as I said, like Analog Devices, TI, Microchip, and so on. They are all working on a mating phase because it's all the same protocol. It's all the protocols are standardized by the IEEE, and it doesn't really matter. And therefore, the necessary chips will be done by the chip manufacturer, and this is not depending on the interface, on the different interfaces.
Okay. User asked, so in the last couple of days we saw some competitors putting their activities together. Compared to that, what is the advantage of the SPE Industrial Partner Network?
Well, the industrial single-pay Ethernet industrial partner network, the biggest advantage really is a legal association in Germany. So there are contracts behind that, and also they committed to one standard. And this is very, very important. And this is not just I can go to a company and ask them, hey, do you like single-pay Ethernet? And if you say yes, will you show up on my webpage? Yeah, no problem. This is not how it works for the single pair Ethernet industrial partner network. We really have a vote in this partner network if we accept new members. And all of our partners really want to provide solutions in every corner of the ecosystem. And I think that really is the biggest advantage, to really, they all have one common goal: to establish single pair Ethernet. I mean, in our partner network, also from HARTING's perspective, we have competition with TE, Amphenol, Heroes. This in connector business, these are also competitors. But we came all together to focus on single pair Ethernet and to push this whole technology forward. And this can't be done alone. And that's why we have the industrial partner network.
Okay, many thanks. I can see we have such a huge number of questions that would take us another 20 minutes to answer them maybe. But as we run into the full hour, maybe we can pick up the next 3 ones. The next one will be a very short but very meaningful one. When will samples be available for the T1 industrial?
Yes, that's a very good question. Samples, especially the IP20 version, we will start with that version, and this will be available at the end of the month. And yeah, then we will have the first samples out. And of course, if you want for test applications, you can always ask us that we can support with cables, connectors, and so on.
Okay, and then again, some variations of the question. Is there a possibility to transmit power over SPE, and how can it be done?
Yes, this is possible. As I showed in my presentation, power over data line is the remote powering standard for that. It's the equivalent to power over Ethernet, and we can transmit up to 50 watts with power over data line. And yeah, the rated voltage, for example, at the power sourcing equipment is either 12, 24, or 48 volts. And if you need higher power if you need higher power, we also have the M8 hybrid version where you have 2 single pair Ethernet contacts and also 2 power contacts.
Great, and then yes, let's pick up the final one for this live session. It's about media converters. So someone asked, will there be media converters from 2 or 4 pair Ethernet to single pair Ethernet?
Yes, of course, media converters will be also important to transmit from 1 pair Ethernet to 2 or 4 pair Ethernet. And especially if you're coming from the field to a media converter with 3 single pair Ethernet ports, and then you want to go with 4 pair Ethernet to a different machine. Yes, they will already work on that, but of course this also relies on the chip manufacturer, because we need PHYs for that.
Great. As I mentioned, so we have a really exciting number of questions we have not answered so far, but I think, Fabian, we can promise we will pick them up afterwards and get in touch with you to answer those questions. Great. Yes, and that brings us to the end. Fabian, many thanks for this exciting insights and answers. So yeah, what a lot of fun.
Yeah, thank you for having me. Thank you to you all for your time. And hope I see you in the next webinars. And if you have questions, just write us an email, and we will answer them, and we will come together. Thank you very much. Have a good day.
Great, yeah, and if you have enjoyed again it as well, be there next time. The next webinar is coming, and it will be held on the 9th of June with the topic how to establish barrier-free sensor to cloud communication. So there's the next one. You can register for it. As you know, the industrial Ethernet trends are part of the HARTING Experts Camp, or digital contact point for webinars, talks, and presentation. Yeah, just have a look at the agenda. We'll send you the URL for it with the webinar recording. That was it from today's webinar. Many thanks. Thank you very much for joining us. Stay healthy and see you next time. Goodbye.